Our goal today is to compare linear, quadratic, and exponential graphs. The graph that is a straight line is linear. Its function rule is y equals mx plus b. A quadratic is where there is a parabola, where two lines never touch. The function rule for that is y equals ax squared plus bx plus c. Our third graph is where the coordinates never quite touch x but runs very close. The function rule for that is y equals a times bx. So first we are going to look at what a linear graph looks like. A linear graph is y equals mx plus b. This is an example of what a table of data would look like for a linear graph. It is where the first common differences are all the same. So in this graph, the first common differences are 4. Notice how they are all positive 4. None of them are negative. Also on this side, they are all the same, positive 1. Therefore, since they have a common difference of 4, this table of data is linear. Linear is always when the first differences are the same. Example we're going to look at is a table of data that shows what a quadratic graph looks like. A quadratic graph is when the second differences are all the same. So let's take a look at the table. Here we have the first differences are not the same. As you can see, there's negative 14, negative 4, positive 6, positive 16, and positive 26. None of those are the same. Also, we have negatives and positive, which is not good. So, our first differences tell us that this graph is not linear. Now let's take a look at our second differences. So, our second differences are plus 10, plus 10, plus 10, and plus 10. Therefore, we know that this graph is quadratic since the second differences are 10. And they're all the same. Now let's look at what a table of data for an exponential graph would look like. An exponential graph is when the ratios are all the same. So take a look here. The first ratios are all multiplied by 3. And notice how they are all the same. So therefore, this graph shows that it is an exponential graph since all the ratios are the exact same. The difference between 1/9 to get to 1/3 is multiplying by 3. The difference between 1/3 to get to 1 is multiplying by 3. 1 to get to 3 is multiplying by 3. 3 to get to 9 is multiplying by 3. And also on the x side, they are all plus 1. Therefore, we know that this graph is exponential. Okay, so now we are going to practice identifying the table of data, whether it is linear, quadratic, or exponential. So first we are going to take a look at the common differences. The first common differences for this table. Let's find them. So, to find them, I like to subtract 8 from 20 and see what you get. You get negative 12. And then I like to subtract. Then we'll subtract 3.2 from 9, and you get negative 4.8. And this one is negative 1.92, and this one is negative 0.768. Therefore, what does this show us? This shows us that this graph is not linear because the first differences are not the same. So now let's take a look at the second differences to see if it is quadratic. So the difference between these two numbers is 7.2. These ones is 2.88. And this one is 1.152. Therefore, this also shows us that it is not quadratic because the second differences are not equal. So our next hope is to figure out the ratios to figure out if it is exponential. So when I figure out the ratios, I like to divide. So we are starting back up here. So I like to divide 8 divided by 20, and then you'll figure out the difference between these two rationally, which would be 0.4. Then the difference, so we go 3.2 divided by 8, you get 0.4. Is everyone following along with their calculators? Then here you go, 1.28 divided by 3.2 equals 0.4, and this one is 0.512 divided by 1.28 equals 0.4. Therefore, these are all the same. So we know that it is exponential. Always be careful that when these decimals are close, it could still be exponential, that your calculator might just round it up to it.